I study exoplanets. These are planets outside the solar system, orbiting stars other than the sun. We discovered the first exoplanet only about 30 years ago, detected by a minuscule dipping of light that occurred again and again as the shadow of that alien world passed in front of its host star on its orbit. How many exoplanets do you think we've found now? Well, thanks to recent telescope surveys, just last month, that number passed 5,000. Like other exoplanet astronomers, I use specialized software to analyze telescope data of these numerous alien worlds. And what we found is surprising. Most exoplanets are totally unlike the planets in our own solar system. We found hot, gas giant planets orbiting super close to their host star, and planets with densities as light as that of cotton candy due to thick, dusty atmospheres. And the strangeness of these alien worlds means that the story of how planets form is much more complex than anything we previously imagined. So, how do we uncover the secrets of planet formation? Well, we can start with the stars that planets orbit. And that's because the characteristics of host stars, like how bright they are and what they're made of, encode clues on how their planets came to be. In my thesis, I look at the amounts of different elements in stars because each unique chemical fingerprint tells us something about the planetary system's formation. So far, I found host stars rich in rocky elements like iron. This is a sign that they ingested planetary material, maybe consuming their own planets in an act of engulfment. These systems tell us how much rocky material is typically eaten by stars and how much is left to form planet cores. And that reveals what kinds of planets eventually form. If there's lots of uneaten rocky material available, planet cores can build up fast and then accrete huge amounts of gas to form Jupiter-sized worlds. And if there's not much rocky stuff around, smaller Earth-like planets are more likely to form. I'm going to combine this work with another area of astronomy, galactic archaeology, which treats the chemistry of stars as artifacts that allow us to reconstruct the history of our galaxy, the Milky Way. By looking at rocky chemistry and galactic archaeology data sets, we can learn if small planets that may host Earth-like life are common throughout the galaxy, or worlds with different sizes, made of more exotic compositions, that could be home to something a little stranger. Then maybe we can answer the question, why are we here in this part of the galaxy and not somewhere else? So, just 30 years after we discovered the first exoplanet, it's now possible to investigate how planets form on a galactic scale. Who knows what discoveries of worlds beyond the solar system and what it means for our cosmic origins the next few years will hold. Thank you.
Thank you.